Welcome to AI TechBook. Today, the reason your agent's shared memory works in the demo and quietly corrupts in production. The first time I gave a fleet of agents a shared memory, it felt like magic. One agent learned something, wrote it to a shared vector database, and every other agent just knew it. In the demo, that was the whole dream. A team of agents with one brain. Then I scaled it up. More agents, all writing. Different agents allowed to see different things. Facts that were true on Monday and wrong by Friday. And the thing I trusted most, the shared memory, started feeding my agents confidently wrong answers. Watch that shared slab crack. 4 fractures, and every one of them cost me a day. Because a vector database gives you storage and search. It gives you no rules. And at fleet scale, the missing rules are exactly what breaks. Failure 1. In the demo, every agent could read everything, and that was fine. I trusted all 2 of them. Then a memory I'd written for one customer showed up in an answer for a different customer. Nothing was hacked. The retrieval just did its job. It returned the nearest match, and nearest has no idea who's allowed to see it. Watch that red cross the boundary and the tile bleed red. That's unauthorized leakage. Memory readable across lines it was never meant to cross. A shared index has no concept of who is permitted. The first thing a fleet memory needs is scope, and a raw vector store has none. Failure 2. A fact was true when I wrote it. Then it changed, and the memory didn't. Here's what actually happened. The old version kept getting read and reshared and copied across the fleet, while the corrected fact sat right there, ignored. Every agent that read the stale copy was now confidently wrong, and they were teaching each other. Watch the old fact spread, agent by agent. I thought this was a refresh problem. Just re-index more often. It isn't. Staleness is a provenance problem. Nothing in the store knew which version was supposed to supersede which. A memory layer needs a sense of time. A bare index has no clock. Failure 3. 2 agents wrote 2 facts about the same thing, and they disagreed. I expected one to win. Neither did. Both facts sat in memory, both retrievable, both ranked by similarity. So depending on which agent asked and how it phrased the question, it got a different answer to the exact same thing. Watch both cards light up and the spark crack between them, with nothing deciding a winner. That's contradiction persistence. A vector store will happily hand back 2 opposite memories because similarity has no opinion about truth. The fleet needed a rule for precedence when facts collide, and nearest vector is not a rule for truth. Failure 4 is the quiet one, and it's the one that made the other 3 unfixable. Every memory came from somewhere, but I couldn't prove it. When I tried to debug the bad answer, I followed the chain. This fact was derived from that memory, which came from that source. And halfway back, the links just dissolved. No writer identity, no origin. The fact was floating with no history. Watch the chain draw in, then break. That's provenance collapse. And here's why it's load-bearing. Without provenance, I couldn't debug the bad answer. I couldn't revoke the poisoned source. And I couldn't even resolve that contradiction from a second ago, because I didn't know which writer to trust. Here's what actually fixed it. And it wasn't a bigger database. It was 4 governing primitives, and each one heals exactly 1 crack. Scoped retrieval decides who can read what. That heals the leakage. Temporal supersession lets a new fact retire an old one. That heals the staleness. Provenance tracking, records origin, writer identity, and the full derivation chain. That heals the contradiction and the collapse. And policy-governed propagation sets the rules for how knowledge crosses agent and tenant boundaries. Watch each primitive draw in and its crack heal. Same memory, now governed. None of these is a bigger index. They're governance built into the layer. And it holds. The paper that formalized this reports reconstructing 4 deep derivation chains with the right writer every time in under a second per hop and 0 leakage across the fleet. 4 things to remember. 1. At fleet scale, a shared vector database breaks 4 ways. 2. The breaks are leakage, staleness, contradiction, and lost provenance. 3. Each one has a governing primitive: scoped retrieval, temporal supersession, provenance tracking, and policy-governed propagation. 4. It's governance built into the memory layer, not a bigger index, and it holds under test. Shared memory needs governance, not just a vector database. Next time your agents disagree or leak, check the memory layer's rules before you blame the model. Thank you for watching. If this reframed how you think about agent memory, share it with someone who's wiring up a fleet right now. Subscribe to AI TechBook. Next time, we go hands-on, scoping and versioning a real agent memory store.